Okay, so let's flip back to our slide, and we're in about part C. So we just calculated the mean and sample standard deviation over here. So we had a mean of our sample was 3.8 letters, and the standard deviation of our sample was 2 letters. And now in part C, we want to use the central limit theorem to calculate the standard error for the sampling distribution for the sample mean. Okay, and so recall from the central limit theorem, we find the standard error by taking the standard deviation of the population and then dividing that by the square root of the sample size. So we've got sigma x bar in this case, and I want to use the standard deviation not of the sample but of the population. So in place of sigma sub x, we're going to put the standard deviation of the population, which is the square root of 3.45. So we take the standard deviation of the population, divide by the square root of our sample size, giving us a standard error of 0.34 approximately. Okay, and so lastly, part D, they're asking us to give an interval of values that's going to have a 95% chance of containing the actual value for the population mean mu. Okay, and so recall that if I go approximately 1.96 times the standard error below the sample mean, that's going to give me the lower cutoff for that interval. So my sample mean is 3.8. And if I go 1.96 times the standard error for the sampling distribution, that gives me an approximate value that comes out to be approximately 3.13. And we can get the other cutoff, sorry, I forgot the 4. We can get the other cutoff by going 1.96 times the standard error above the sample mean. So now I add 1.96 times 0.34, and that's going to give me the other cutoff, the upper cutoff for this interval, which is about 4.466. And so now we've got our interval. So if I go from 3.134 up to 4.466, right here I've got an interval that I've just boxed in blue. This interval has a 95% chance of containing the actual value of mu. So I don't know actually whether the sample I got actually was a successful interval. So I don't know if this is a successful interval, but what I do know is if I construct my interval in this way, 95% of the time it will be a success.